Alright, so in this video I want to take a look at being able to use multiple different catch blocks with a single try block, as well as being able to use a multi-catch block, which is capable of catching multiple different types of exceptions within a single catch block. So to do this, I'm going to go ahead and create a new program or a new project. And for this particular program or project, what I'm going to do is create something that I'm going to use to read from another text file, so kind of like our IO exception demo. But in this case, now what I'm going to do is read from a file that will consist of a sequence of data points. So the name of this program or project, I'm going to go ahead and call this data reader. So then we'll have our class header, so say public class data reader. Then have our main method. So our public static void, and then our string array of arguments. And so what this is going to do is we want to establish a connection with some text file that will consist of a sequence of data points, and we want to read from that text file. And the way that we're going to establish that connection is by letting the user specify the name of the file that they want to read from. And then we'll go ahead and start reading through it by essentially getting each integer value from it. So one of the key distinctions here is going to be the fact that we're dealing with the next int method rather than the next line method when we start reading stuff from this file. So the key things that I want to test out when it comes to exceptions, again, we can still look at what happens when we misspell the name of the file. So we can see like a file not found exception. I also want to take a look at what happens whenever we give it some kind of faulty value inside of the file itself, so that whenever we're actually in the process of reading from it, we might encounter some additional exception based on that. So in order to get started on this, we're going to go ahead and do our imports. So import java.io.star. Go ahead and do that wildcard import to just bring in all of the classes from our IO package. And then we'll go ahead and import a scanner as well, since we're going to be letting the user read from, or we're going to be reading from the user's input, and we also need the scanner to establish a connection with the file to read from that as well. So as far as our variables go, we know that we're going to need a scanner object. So let's go ahead and make a scanner called keyboard. So be equal to a new scanner that is reading from the standard input stream, so system.in. We'll also go ahead and include an int variable that's going to be used whenever we're reading from the file to hold the individual data points. So we'll say like int data point is equal to 0. In addition to this, let's say in between these, we can also include a string variable that's going to hold the name of the file that we get from the user's input. So we'll say string file name is equal to, let's say an empty string initially. All right. Now that we've got all this, we'll go ahead and create our request from the user to specify the name of the file. So we'll say system.out.print. Say please enter the name of the file. And then underneath this, we'll go ahead and get the next line that they give us, and we'll use that as the name of the file. So we'll say file name, and we'll assign to that the next line of text that they give us. So that's going to be our file name, and we'll use that with a try with resources block. So we're going to still do the try with resources that we just saw. That way then the process of opening and closing the file is a bit more streamlined and a bit more secure. Saves us a little bit of headache as far as adding additional variables. As you may have noticed, I didn't include a second scanner for the input file. Instead, I'm going to go ahead and make that right here in this try with resources. So say scanner input file is going to be equal to a new scanner. And then inside of this, we'll go ahead and make a new file. And then inside of that file, we'll go ahead and specify the file name. Okay, so use the file name, make a new file object, and then start scanning that file object. And then right here, what we want to go ahead and do is start reading off the different values that are inside of it. And we're going to keep doing that for as long as there's some value to read from that input file. So the way that this is going to work is we want to go ahead and say for, or while our input file dot has next. So for as long as this is true, we want to go ahead and keep reading from it. So this is just going to keep scanning through it. This has next is basically going to return either true or false, depending on whether or not we have reached the end of the file, or if there's still something left in the file that we can read or scan off of it. Then what we'll go ahead and do is start printing out each one of those items to our console. So we'll just say just a simple print statement. Say system.out.println, and inside of here what I'm going to go ahead and put is my input file .nextInt. Okay, so with this line right here, we're just going to read each one of those integer values that are in that input file and print those out to the console. And then once we've done all of this, essentially this would be the entire body of our scanner, so this is all we need to include. And then what I want to be able to do is catch some kind of IO exception along the way. And we'll say something like system.out.println. We'll say invalid file IO. Okay. So now that we've got all this, we'll go ahead and also add our text file that we want to read from. So we'll go ahead and make a new file. Again, making sure that if you make this text file, that this is going to be located in the project directory, assuming that you're making this as a project from some kind of IDE like NetBeans. We're going to call this data.txt. And for this data file, I'm going to go ahead and insert a couple of different integer values. So for this one, let's just do something simple like multiples of 5. So do 5, 10, 15, 20, and 25. Just go ahead and save that. And now that we've got all this set up, we'll go ahead and compile and run this program and see what's going on with it. So we're going to compile our data reader.java. Okay, go ahead and compile this, or run this. So we'll go ahead and enter the name of the file. So we've got our data file right here. So we'll specify that name here. And then we can go ahead and just print out the contents of that file to the console. Okay, so then of course, there are a couple of other things that we could do to this to see what happens whenever certain errors occur. So let's say that we run this, but we go to type the name of the file, but I accidentally forget the A at the end. I push enter, we'll see invalid file IO. Another case that we could run into, because of the fact that we're trying to read integers from this, we might also encounter a situation where, maybe we put something that's not right. So maybe instead of saying the number for one of these, we just spell out the number. Or maybe let's go with something that might be more likely. The expectation is that this is a set of integers. Let's say maybe we run into a circumstance where we accidentally put a double or a float instead of an integer. Okay, so just a very small mistake could happen. And we want to go ahead and run this and see what happens whenever we hit that integer with this scanner right here. So coming over here, go ahead and compile this. Go ahead and run it. So far compiling it and running it, no problems. We're going to specify the name of the file. When we hit that, it's going to go through this, and then we're going to get this exception right here, and it's going to say something like java.util.input mismatch exception. So we're running into a bit of an error right here. So what we need to go ahead and do is try to make sure that we can actually catch this error as well. And the way that we can do that is we want to specify something about input mismatch. Well, input mismatch is not really related to IO exceptions, and because of that, you'll notice that we got this entire exception message printing to the console instead of just invalid file IO. So in order to fix this, this is a good opportunity to go ahead and introduce what is known as a multi-catch block. So a multi-catch is where basically what we can do is just specify a character like this to separate out our different types of exceptions, and then also go ahead and specify the other kinds that we want to catch, say like this input mismatch. So go ahead and add that here. And then one additional thing to note about the syntax of a multi-catch is that when we specify the variable name, we can only specify a single variable, but the data type is going to be essentially what it's picking from based on the kind of exception that it's catching. So we're going to say something like IO exception or input mismatch exception. Essentially, this is how we can read this. And then we'll go ahead and give it that variable name. And so what we can go ahead and do here now, instead, rather than just simply saying invalid file IO, we could say something a bit more general, like something went wrong while accessing the file. Okay, so not necessarily just because of something to do with the file IO, so not necessarily an exception coming from the IO package, could also be this. And since we're including this input mismatch exception, we also want to go ahead and import that. So So we'll do import java.util.input mismatch exception. Okay. So now if we go ahead and compile and run this, so I'll come over here, clear this, compile it, and then we'll run it. And so now when we enter the name of the file, we'll go ahead and give it the correct name, and now it'll run through this, and right at the very end it's going to say something went wrong while accessing the file. So it'll give us this little error warning to let us know that there's some kind of mistake that's been made. Okay. The other kind of exception that I want to take a look at is going to deal with the situation where we want to specify multiple catch blocks with a single try. So there's another way that I could do this instead of just looking at the input mismatch exception. So the way that I'll do that, I'm going to go ahead and comment out this line, and we'll also go ahead and comment out this block. And I'm going to replace this with 2 catch blocks. So the first one will still be used for IO exceptions. And we'll still use this to just say that we have invalid file IO. And then what I want to go ahead and do is also include an additional catch block that comes after this. So we'll say catch. And this one's going to be for exception. So in this case now, we're going to deal with just any general exception we might get. And for this one, I'm going to use pretty much the statement that I had here. This is something went wrong while accessing the file. Okay. So we'll go ahead and save all of that. We'll compile it, and then we'll run it. And so now what we can see is what's going to happen whenever we specify different kinds of errors. We now have different types of catches and different error messages that we can print to the console. So if we do something like, say, misspelling the name of the file, say we forget that A again, we'll see invalid file IO. But now if we run this and we give the name of the file correctly, but we encounter that error within the file itself because we didn't read it properly, because we didn't have an integer at one point, we'll now see this error message instead. So there's a couple of things to note about these 2 different approaches. So I want to go ahead and take a look at that as well. So we're going to describe conceptually what's going on here. So we're going to take a look at essentially the 3 types of classes that we've been working with up to this point. And these 3 classes are going to be the exception that we have at the very top, so we'll place that here. We'll then have our IO exception. We'll go ahead and place that right here. And then we also had our input mismatch exception. And we'll go ahead and place that over here. I think that just barely fits. And then the other thing to note is the relationship between these. So we know that both IO exception and input mismatch exception must inherit from the exception class. It's just kind of a given. So the thing to note about the relationship among these different classes, when we're dealing with the first example that we saw, which was the multi-catch, this is best used whenever we are dealing with 2 types of exceptions that don't really have an inheritance relationship between them, say like IO exception and input mismatch exception. These are more like sibling classes rather than a parent or a child class. And so that makes more sense for the multi-catch, because now what we're going to do is just try to catch one or the other. In the case of inheritance, say we have a parent-child relationship, this is where this idea of using multiple catches like this starts to make more sense. And the reason why we want to do it this way is because of what is known as a polymorphic exception. So if we think back to this idea of polymorphism, this concept of having many forms, then there's actually a particular way in which we want to approach building out the code for this. So we'll notice that the exception class is more general than the IO exception. So let's see what happens whenever I take these 2 and I just invert them. So I'm going to go ahead and put the exception first and then the IO exception. And then we'll go ahead and compile this. So when we compile this, we actually run into an error because of this. And the error that it's saying is that we say exception, IO exception has already been caught. And what this is trying to tell us is that because of the order that we put this in, because exception is more general than IO exception, technically, anytime that we run into an error or an exception somewhere in our try block, even if that is an IO exception, technically, because an IO exception is a type of exception, it's going to get caught right here, and it will never see this catch block. Okay? So the order that we put these in determines the order that we're going to look through each one of these to decide which kind of exception we need to needs to be applied. So the general rule of thumb is whenever we're dealing with multiple types of exceptions like this, we want to make sure that we are applying the most specific exception first and then moving towards the more general exception. So one of the things I want to go ahead and include right here, just to make sure that we understand this distinction. Let's say polymorphic exceptions. So that's referring to this portion right here. And then when we deal with multi-catch blocks, that's dealing with this right here. So keep in mind that this is the part that addresses polymorphism, and this is the part that's addressed using the multi-catch blocks. So I want to go ahead and remove all this and describe a little bit more about that relationship with polymorphism. So the way that it works, the reason that we want to do the most specific to the most general, in addition to the fact that Java itself will complain about this, it also makes intuitive sense that this is how we want to approach this. And the reason is because if we think about it in terms of, say, a particular box or particular space, imagine that this space right here is the most specific type of exception that I'm trying to catch. Let's say that surrounding that is some more general type of exception. And then surrounding that is yet another even more general type of exception. And so what's going to happen is if we try to do this the other way around, where we're catching the more general ones first, in addition to the fact that this will kind of overlap or just shadow our more specific exceptions, there's also the fact that it becomes more difficult to recognize exactly what went wrong if we're giving a more general error message. So while I mentioned before that we want to try to be careful about providing too much information whenever we are explaining to the user what went wrong with our exceptions for security reasons, it's also very important that we do at least provide enough information for them to be able to distinguish between one type of error and another. So in some cases, if you're dealing with something that's fairly complex with a file system, it might start to make sense that you do go ahead and include that error message of letting the user know that the file was not found versus maybe an issue with trying to read from the file itself. So maybe in this case what we can go ahead and do, we can go ahead and change this back. So we'll go ahead and revert the order back to what it was originally. And then instead of just saying invalid file IO, we might provide something a little bit more specific about the kind of IO exception that we're expecting here, which would be that the file was not found. So we might go ahead and do something like this instead. And then for this one, when we say something went wrong while accessing the file, we could say that something like invalid line read from file. Okay. So now we have a more clear distinction between this kind of exception and this kind of exception with these messages, so we can at least provide a little bit more information to the user. And of course, the expectation here is that you'll have to decide for yourself situations where it would be appropriate to go ahead and do this, and other situations where it would be more appropriate to exclude or kind of obscure information like this for security purposes. So we can go ahead and recompile this. And we'll go ahead and run it. And so now whenever we try to specify some information about it, say if we say the name of the file correctly, we can get all this to print out, but now we'll say invalid line read from file, so we can see what the error is there. And then if we run this, but we make a mistake in spelling out the name of the file, then it's just going to say file not found, which kind of hints at a little bit about what's going wrong there. Okay. So this is going to wrap up everything for these polymorphic exceptions as well as this multi-catch block. Going into the next video, we're going to start transitioning away from talking about creating our own try-catch blocks and discuss a little bit more about what is going on in the background for Java by talking a little bit about the stack trace as well as how that can contribute to debugging